Hi guys, in this video, I'm going to cover the chapter 3, which is about the national income. So the chapter 3 mainly talks about what determines the economy's total output and income. So here the total output is same as a GDP. Okay, and then through this chapter 3, we're going to study about the prices of the factors of production. So like I told you, we have 4 factors of the production, or you can say that resources, right? We have a land, labor, capital, and entrepreneurship, right? But we're gonna use the labor and capital only to make it simple. Okay, so here, prices of the factors of the production, such as the labor and capital. As you know, the labor price, we call it the wage, and then the price of the capital, that's the rental rate. That is same as the interest rate. Okay, and after that, we're gonna study how this total income in this economy is distributed. So that's the labor income and capital income. Okay, and we're gonna also talk about the demand for goods and services, how they are determined. Okay, and then the last one is the equilibrium in goods market. All right, so this is the outline of the model. So we study the closed economy model, so that means that there is no trade, so we don't need to study the exchange rate yet, but we're going to cover that one later. And so here we start with the closed economy, and we assume that the model is a market clearing. That means that demand equals supply. So that's the market clearing model. And supply side of the output, demand side of the output. So supply, we're going to study about the production function, and pretty simply, we're going to have this equation. Y, the output, the real GDP, equals F of the K and L. So F is a production function, and in order to make the output, you need to have the capital, you also need to have the labor, and then you're gonna have the production function, which captures the technology, right? So then you will have the output. So are you guys with me? So you need to make the output, then you have the capital, labor, and production function, the technology, then you can make the output, okay? And then the demand side of the output, so basically we had this equation, y equals c plus I plus g. Because at here, we assume that the model is a market clearing model, so that's why the demand side, the supply side, we have the same, y equals something, but these are the same. The output, the supply side, equals the demand of the output, okay? And after that, we put it together, we're gonna have the equilibrium, and we have a goods market, and we have a hypothetical, the market, which is the loan funds market, to understand the economy. All right, so the factors of the production. So K is a capital, K denotes capital, and R is a labor. The reason that we use a K for capital is that we already use a consumption for C, right? So consumption, we denote the C, so that's why the K is a capital. And then the capital, for example, we have a tools, machinery, structures used in productions. So like buildings, that is a capital. On the other hand, the labor, the physical and mental effort of the workers, that we call it the labor. Okay. Now we have a production function, y equals F of K and L. So to remind you, this is algebra. So you have the x variable, and then you have the mapping from the x to y, that's the function f, right? So they basically same thing. You have the inputs of labor and capital, and then, so you are having the labor and capital, and then we can find the mapping from the resources to the output, okay? So it's the same structure. So by having this production function, we can show how much output of the economy can produce from the capital and the labor, okay? And this production function reflects the economy's level of the technology. So this is good to know. Like we have the advanced country, and we have a developing country. And in the middle, we have an emerging market economy. Emerging market economy, okay? So advanced country, US, Canada, and some European country. These are the advanced country, developing country. For example, you can come up with, I don't know, so like some unknown country, let's say. I don't want to mention the specific country here, but the emerging market economy is in the middle. So for example, China is an emerging market, and Korea is also an emerging market, okay? So the advanced country in general, they have a better technology than the developing country or the emerging market economy, okay? And from this production function, we're gonna study about the constant return scale, which requires some basic math, okay? But I'm going to talk about the details step by step. So returns to scale, let's say we have the production function F and we have a capital, the first unit, so K1 and the L1, okay? Now, when you multiply the capital by Z times, then that's a K2. So for example, Z is a 2, and the first capital K1 is a 3. And then the first labor is a 4. So you have a 3 machines and the 4 workers, right? So K2 is a Z times a K1, that is 2 times 3, 6. And then L2 is a Z times L1, that is 2 times 4 is 8, okay? So basically, when I put the Z equals 2, that means that I doubled my inputs, okay? Then from here, we get to know, well, when you double the input, output is also double, then we call it the constant return scale. What does it mean? So let's say you have, so same thing, K1 equals 3, L1 equals 4. So that means that you have a 3 espresso machines and the 4 baristas. And then per hour, you can make 100 cups of coffee. We good? Now, when you double the inputs, like you have 6 espresso machines and you have 8 workers, 8 barista, if the Y2 is 200, that means you double the input and output is also double. That means that that's a constant return scale. Then the other 2 is a straightforward. So increasing return scale, that means that, well, you double the input, but somehow the output is more than double, such as 300, that's an increasing return scale. Again, you double the input, right? So from the K1 to K2, L1 to L2, you double the input, but then the output is triple, that is increasing return scale. On the other hand, the decreasing return scale is that you double the input, but the output is less than double, such as a Y2 equals 150. Okay, so increase by the 50%, so 150% only. Okay, so then that is a decreasing return scale. Okay, so the equation itself, like a little bit confusing, or it looks like a complicated. It's nothing. So double the input, output is also double. That's a constant return scale. You double the input, but output is more than double. That's an increasing return scale. You double the input, output is less than double. Then we call it a decreasing return scale. Okay. Now let's cover some example here. We have the production function, which is given as a square root K times L, right? Now, the easiest way is you play with the numbers. So let's say you can come up with any number, but it's good to use the integer to make it easy. So for example, L1 equals 1, K1 equals 4, okay? So then the output is f of the K1 equals 4, L1 equals 1, then square root 4 times 1 is a square root 4 is, that is 2, okay? Now, you double the input. So I'm using the Z equals 2 because it's easy to handle. So then L2 is 2 times the L1, right? So that is a 2. And K2 is 2 times the K1, that is 8, right? So basically here, you have the 1 worker and then 4 espresso machine, then you make 2 cups of coffee, but then you double the input. Now you have 2 workers and 8 espresso machine. Then you want to know how many outputs you can make. So K2 equals 4, L2 equals 1, L2 equals 2, sorry. So then the square root 4 times 2 is a square root 8, right? So that is a 2 times square root 2. What do you see? You double the input, but then output is, what happened? It's less than double, right? No, give me 1 second. I think that I made a mistake. So L1 equals 2. Oh yeah, so here, K2 equals 8, right? So K2 equals 8, so but somehow I put the 4, so here. Sorry about that, so let me fix it. So when you double the input, you have now the 8 espresso machine and 2 workers, so square root K times L, so 8 times the 2, that is square root 16, that is 4. Then what do you see? Well, you double the input and output is also double. So that's why this one represent constant return scale, CRS. Now, following example. Here, again, you can play with the number. That's the easiest way. So K1 equals 1, you can come up with any number, but it's better to use the integer to make it easy. So K1 equals 1, L1 equals 1, then the output is K1 equals 1, L1 equals 1, L1 equals 2. You just need to plug in. 1 squared plus 2 squared is a 1 plus 4 is a 5. Now you double the input, then K2 equals 2, L2 is a 4. Then f of the K2, which is 2, L2 is a 4. Then 2 squared plus 4 squared is a 4 plus 16. That is 20. Then what happened? You double the input, but output is 4 times, right? That means you have a more than double. That's an increasing return scale. Okay? There are more examples, so you can play with that way. So plug in the numbers, then you can find it. But this time, let me use a Z, so like a general way to solve this question. So the question number A, f of the ZK and then ZL. Then the numerator is you replace the K with a ZK. Why is that? Here K, you plug in the K squared, right? And if this one is a ZK, then you need to plug in the ZK, right? So that's why the numerator is a ZK squared, okay? And then the numerator, you replace the L with the ZL. Then what happened? The numerator is a Z squared K squared, and denominator is Z times L. Then this Z cancels out. Then you have ZK squared over L. Okay. What happened? You multiply by Z, but then the output is multiplied by the Z. So here. So when you compare this and that, this is multiplied by Z. Again, you multiply your input by Z times, but then the output is also Z times, right? So that means that the first one is a constant return scale. So you do the same thing for the question number B. You replace a K with a ZK, L with a ZL, and then see what happened to the output. Well, you put it out the Z outside of the parentheses, then what happened? Output is also also multiplied by Z. That means that this also represent the constant return scale. Okay? That's how you play with this return scale. Okay? All right, so move on. Now, let's talk about the production functions a little bit more, and then talk about the national income. So here, to make it simple, we assume that the technology is fixed. That means that over time, it does not change. It is not changed, right? So that's what that means. So today's production function is same as it goes forever, as long as there is no mention about the technology, right? To make it simple. And then the economics of supplies of the capital and labor are fixed too. So that's why we put the bar. Okay. So we have factors of the production, labor, and capital, but then we want to make it simple to analyze it. So that's why we have two assumptions. One is technology is fixed over time, and the other one is labor and capital is fixed. So that's why we put the bar. Bar means that it's a fixed, it's not average. Okay? So from here, we get to know, all right, so we have the factors of the production such as labor and capital, but we want to make it simple. That's why we assume that this labor, number of the workers, and capital is not changed. And then since we have the production function, which is not changed too, then we get to know how much we can make the output. So this production function and the factors of the production together determine the output. Okay, so determine the output. And then we want to know how this output determines the national income. Okay, so that's the following question. All right, so let's move on. And this following page just give you the idea. Okay, so because of assumption that capital is a fixed, labor is a fixed, and also the production function is not changed. So that's why the left-hand side, the output is also fixed, okay? And you may ask me why we need to have this assumption. So the idea is very simple. We can relax that assumption later, but we want to make it very simple. But even though the model is very simple because of the assumption, bunch of the assumption assumptions, but still it gives the insight, and we can understand what's going on in the world by using this very simple model. All right. So then the following question is, what's the distribution of the national income? Well, you have the income comes from the labor and capital, and we want to know about the distribution. Okay, but before that, we need to know the factor prices. So like I told you in the beginning, price of the labor is a wage, and the price of the capital, that's a rental rate. And you can think that the rental rate is same as the interest rate. Okay, so here is a notation. We use the uppercase W as a nominal wage, and then here we have a price level. Okay, so that is the same as the price of the output. Then when you divide it by this, when you divide this nominal wage by the price, then it becomes a real wage, and I denote the lowercase w to represent this real wage. Okay? And then the rental rate is the same thing. You divide it by price level, then it becomes a real rental rate, and I denote the lowercase r. Okay? All right. So one example. Let's say that your nominal wage is a $15 minimum wage, and then the price of the output that you make is a hamburger, and that is $3. Okay, so then your real wage in terms of the hamburger is a $15 divided by 3, so that is 5. So your real wage is same as 5 hamburgers. Okay. All right. So then the question is, how do we know about the price, and how can we find the price? Okay, so it's just simple demand and supply. Okay, so factor prices such as the wage and the rental rate determined by supply and demand in factor markets. So we have factor markets means that we have a labor market and we have capital market. Okay, so two markets. Okay. So basically, demand and supply means that same as before, the y-axis is a price, and this is a factor prices now. Factor price. And the x-axis, the quantity of a factor. So it could be the wage, labor market, right? So the in the case of the labor market, the y-axis is the wage, and the x-axis is the number of workers. If this one is a capital market, then the y-axis is the rental rate, and the x-axis is the quantity of the capital. Okay, so we have a downward sloping demand curve. So factor demand is a downward sloping. Why is that? So let's say that you are a business owner, okay, and in order to run your business, you need to have the workers, you need to have the capital, right? But just talk about the labor. So you want to hire the workers, but if the wage is high, then you want to hire less people, right? Because it's too expensive to have the many workers. But if the wage is cheap, then you want to have the many workers, right? Because there is no burden to have more workers. So that's why it gives you the downward sloping factor demand. But what about the supply? Do we have an upward sloping supply? Yes, but we made an assumption the labors and capitals are fixed, right? So that is, this factor supply is a vertical by the assumption. Okay, so be careful. In general, yes, we can have the upward sloping factor supply, but because of the assumption that we made, labor is a fixed, capital is a fixed, that's why the factor supply is a vertical. Then from there, you can find equilibrium factor price. Okay. All right. So then let's talk about the labor first. So assume that markets are competitive. So what does that mean? The markets are competitive. So it comes from the micro. So we have 4 markets in general. So perfect competition. And then the extreme departure from the perfect competition is a monopoly. So when there is a one producer, and then if there are 2 or more, but less than 10 in general, then we call it the oligopoly market. And then the last one is a monopolistic competition. But I'm not going to talk about the details because this is a macro course. But here I want to talk about the perfect competition. So it's nothing but there are so many buyers and sellers, and none of whom can affect the price. Okay, so they are the price takers. They cannot affect the price. So the price is given through the market. Okay, so market determines the price because there are so many buyers and sellers. So that means that they don't have the market power. Okay? So that's competitive means that here each firm takes the W, R, and P as given. So you got it, right? So perfect competition means that there are so many buyers and sellers and none of whom can affect the price. And here, since the markets are competitive, that means that each agent, they need to take the price as given, okay? So here the demand for labor, the basic idea is a company hires each of the unit of labor if the cost does not exceed the benefit. What does it mean? Well, you are a CEO of a company, right? And then you want to hire people, then you're gonna compare the cost and benefit. Okay, so cost and benefit. If benefit is greater than cost when you hire a worker, so then you're gonna hire that person. Okay, but what if the benefit is less than cost? So, for example, you need to pay him the $15 per hour, but his contribution to your company is less than $15 per hour, then you don't have an incentive to hire that person, right? So you don't hire him, or you can fire that person, okay? And here, the benefit is a margin per labor. So that's a new terms that you never heard probably. But then the cost you already saw, that's a real wage, right? So because when you hire workers, you need to pay them the real wage, that's the cost. So what about the margin per labor? So margin per labor is coming, so here. The extra output the firm can produce using an additional unit of labor. That means, so let's say that you hire one additional person and he will contribute the output, right? So that's the margin per labor. So for example, you have the one barista, you one worker, and you have a one espresso machine. And per hour, you make 10 cups of coffee, okay? So that's the current situation. But let's say that you have the one more workers. Now you have two workers and you still have the same espresso machine, one espresso machine. Then let's say because of the you hire one more person, it turns out you can make this company makes 15 cups of coffee per hour. So then this second person, his contribution to the output is 5. So the difference. So then you can understand this equation. So you don't touch the capital, right? So capital, so that means that here the espresso machine is same as a 1, right? You didn't touch. But then you have the one more person, right? So L plus 1. And you compare with these when you have a less worker. So you have 2 workers and the 1 worker and check the difference. So here, like I did, so 10 cups of coffee, 15 cups of coffee. So 15 minus 10 is a 5, right? So from there, you get to know that his contribution, that's the margin per labor, and that is a benefit of having additional worker. One more time. So from here to there, you can see that when you hire one more person, you realize that you can make 5 cups of coffee more than before, right? So that is his contribution, and that we call the margin per labor, and that is a benefit of having additional worker. Okay? Let's cover some examples. Here, we have a table, and then the first question asks you, determine the margin per labor at each value of the L. So when you have the 0 workers, so there is no margin per labor, you cannot find it. But then when you have the first worker, what happened? You have the 10 outputs, right? So the difference from the previous here, the 0 and 10, the difference is 10. So the ampere is 10. And then when you have the one more worker from the first worker, now you have 2 workers. His contribution of the second worker's contribution is 9. So on and so forth. So you can find the third worker's contribution is 8. So the 19 plus 8 is 27. And the difference between the 34 and 27 is 7. And this one is 6, 5, 4, 3, 2, 1. Okay. So we can easily capture this margin per labor for at each value of the worker. Okay. And then question number B and C. So let me use the answer here. So it's coming here. So you can make a graph. So the x-axis is the labor and the y-axis is the output. And you can, just pick up the coordinates. Then you connect this coordinates. Then you can have this curve. And then the question number C asks you to find the graph of the MPL, and the MPL is decreasing. So that we call the diminishing marginal product labor. Diminishing marginal product labor. What does that mean? Well, first worker's contribution is 10. Second worker's contribution is not that much as of the first worker, right? So first worker's contribution is 10. Second worker is 9. Third worker is 8. Fourth worker is 7. It's decreasing. Why is that? Why you have more workers, but then the last worker's contribution is keep decreasing? Why it shows a diminishing marginal product labor? Well, because the capital is fixed. Because the capital is fixed. Well, you still didn't get it? Well, here's an example. You have the 1 espresso machine, and you have the K equals 1 and L equals 1, and you make 10 cups of coffee, right? Now, when you have one more worker, what happened? Because of these two workers using the same espresso machine, that's why the productivity falls. Are you following? So that means that just imagine that you have 1 espresso machine and 10 workers. Is it helpful to have the 10 workers in terms of making the cups of coffee with the 1 espresso machine? I don't think so, right? So that's why it gives you the margin for labor, and it's very intuitive, right? Another example is the following. Well, K is a truck, and then L is a workers. And here, this is a FedEx company, okay? So basically their job is to deliver the package, okay? When you have 1 truck and then 1 worker, okay? So 1 truck and 1 worker, so they can deliver 10 packages per hour. And when you have the 2 workers, they can deliver 20, okay? Well, that's good. But then what happens when you have a third workers? Well, there's no place. There's no seat for the third worker, right? So the third worker has to run when they deliver the package, right? So then the productivity all of a sudden is decreased like a 23 something. So marginal product labor is a decrease a lot, okay? So the point is, because the capital is a fixed and you just hire more workers, then this productivity falls. So that's why the marginal product labor shows a diminishing marginal product labor, okay? So that's why the marginal product labor is a downward sloping. And then from these production functions, well, you can see that the MPL, which captures the slope, right? So you can see that slope is getting flatter, right? So that means the MPL is decreasing. Well, if someone took the AP calculus, AB or BC, or you took the college level calculus, then you can understand this MPL by having derivatives. So this is a redundant, but it's good to know, especially who already took the calculus. So here, MPL is basically dF/dL. What does that mean? You take a derivative, this production function with respect to labor, that's the MPL, and that is a slope. Okay. And then from these curves, you can see that MPL is decreasing as X, the labor, increases. Okay, so that gives you the diminishing margin of labor. And this is exactly the same for the capital. Okay. Yeah. So as one input is increased, its margin product falls. So if L increases while holding K fixed, machines per worker falls. So that's why the worker productivity falls. You can do the opposite. So if you have the fixed number of the workers, but you increase the number of the machines, it gives the diminishing margin per capital. So you have the 1 barista, but then you have a 2 espresso machine, 3 espresso machine, 10 espresso machine, then of course the productivity falls. Okay. All right, so let's cover this example. So which of the production function have the diminishing marginal returns to labor? So in order to check, again, the easiest way is to play with an example, play with the numbers. So here, let me fix the K as a 1, but then I'm going to change the number of the workers. So L1 is 1, so then 2 times 1, 15 times 1 is a 17. Now I have a 1 more worker. So now I put 2 workers. Then what happened to the output? So 2 times 1 plus 15 times 2, that is 32. Okay, so 15 times 2 is a 30, so 30 plus 2 is a 32. Now, let's say we have a 3 workers, okay? So that 2 times 1 plus 15 times 3, that is 45 plus 2 is a 47, okay? Now, you can see that MPL. So from the first worker to the second worker, so second worker's contribution is a 15, and then the third worker's contribution is the difference, that is 15. Then it does not show diminishing marginal returns to labor. Because this is a example, right? It is possible. Okay, this example does not show this diminishing marginal returns to labor. But then the question number B and C shows the diminishing marginal returns to labor. So let me cover the question number 2. No, let me cover the question number C. So let me leave it. Let me leave this B to you. So the C, f of the K1 equals 1, L1 equals 1. So I basically do the same thing, play with the numbers. So 2 times 1 plus 15 times 1 is a 17. Now I fix the capital as a 1, but I have a 1 more worker. So 2 times 1 times a 15, 2 times 1 plus 15 times the square root 2. That is, 1 second. So square root 2 is a 1.414 something. So that gives you, give me 1 second. Let me calculate the real quick. So 15 times. So 1 second. Square root 2 is a 1.414 something times a 15. I'm using calculator to check the number. So this one, approximately 23.2, okay? And then when you have 1 more workers, now you have 3 workers. So square root 3 is a 1.73 something times a 15 plus 2, then I have about 27.98. Okay, so here the difference is a 15.2, but then this difference is, what is it? Let me see, 27.98, 27.98 minus 23.2, I got 4.78. So then obviously you can see that this MPO is decreasing, right? So that's why the third one have third one has a diminishing margins to third one has a diminishing marginal returns to labor. Okay? And of course, let me handle this B by using the calculus. So take a derivative. So here, you take a derivative this with respect to labor, and that is, so you don't touch the capital, but here 1/2 times K to the power of negative 1/2, that is, this one is a labor. That is K square root K over square root L, and here we have a 2, okay? Then this one from here, this one by itself is an MPL. When L goes up, this whole thing goes down. That means that this one shows a diminishing margin for labor. Okay? So even if that you didn't take the AP calculus or the calculus, you can still find the answer by using these numbers, right? Just play with the numbers, you can find it. You don't need to use a calculus. But when you're using the calculus, you can find the answer very quickly and easily. Okay? So that gives you the incentive to study the calculus, right? I mean, in order to study intermediate level or the advanced level, so you probably need to know the calculus, right? So if you didn't take the calculus, but you want to study in depth, then I recommend you to study the calculus. All right, and here's another example. Suppose a W over P, how do you call it? Real wage. You have nominal wage and you have the price, but wage over price that we call it the real wage. You can think that this one is 6 cups of coffee. Okay. And if labor, so you have 3 workers, should the firm hire more or less labor? So basically you need to compare the benefit and cost. Here, W over P, 6, that is a cost that you need to pay. And then the MPL is a benefit, okay? So when you have 3 workers, what happened? The MPL is 8. So 6 is less than 8, so benefit is 8, and the cost is 6. Why not? You need to have him, right? You need to hire that person. Now, when you have 7 workers, then what happened? The MPL, the benefit is 4 only, which is less than the cost, right? So then you have no incentive to hire that person. So then what's the optimal number of the workers that you want to have here? 5 workers, when the benefit equals the cost, right? So this is the optimal number of workers that you want to have. So when you have the 4 workers, the first worker, his contribution is 7, which is still greater than cost, right? So you're gonna have him. And then the 5th worker is the same. Benefit is exactly same as a cost, right? So you're gonna have him. But when you have the 6th worker, then what happens? His benefit, his contribution is less than the cost, then you are not going to have him. So here, having the 5 workers is optimal, okay? All right, so then why do we need to study this MPL and the cost, right? Benefit and cost. Because by knowing this, we can get to know the demand for labor. So basically this MPL captures the demand for labor. MPL is large, that means that we have an incentive to have the workers, right? But MPL is small, the benefit is small, then we don't have the incentive to have the workers, okay? So that's why this MPL itself captures the labor demand, okay? So here, MPL, the benefit equals a cost, and the cost is a real wage, W over P, okay? And by having this equation, we can find the optimal number of workers. When the L is less than L star, then in the case, MPL is greater than real wage. The benefit is greater than cost, then you're gonna hire more, okay? When the L is greater than L star, so you have more workers than the optimal, then in the case MPL is less than the real wage. So then you're gonna fire the workers, so reduce the workers, okay? So that's why we have a downward sloping labor demand. So finally, now we know that why we have a downward sloping labor demand curve, and why we have this vertical labor supply. And the reason was very simple, because we made an assumption to make it simple. So that's why the supply is vertical. And this one tells us the equilibrium real wage, okay? So here, we have just seen that the MPL equals the top W over P. Again, the left-hand side, the MPL is a benefit of having workers or hiring workers. And the right-hand side, the W over P is a cost of having workers, okay? So then we can have the same logic for the capital. So MPK, the benefit of having capital, equals the benefit as the cost of the having capital, okay? And it gives the exactly same. So that's why here, the capital market, so y-axis, the units of the so that's a typo, sorry. So that's the price of capital, which is rental rate. Okay, rental rate is out of it. That's a real rental rate. Okay, and then the supply of capital is a vertical. We have the K bar by the assumption, and the MPK is a downward sloping, same as the labor market. All right, moving on. All right, so then here we're going to talk about the distribution. So how income is distributed to the labor and capital? Well, give me 1 second. Yeah, so there's a typo, sorry. So this is total labor income. So the total labor income is wage times the real wage times the number of workers that you have in this economy. And then total capital income is a rental rate times the capital, the amount of capital, right? That's the capital income. Well, you have no idea what that means. So then here's an example. Let's say, let me make a very simple example. I make $7,000 by working for a company, and I have a labor income, $7,000. So every month I get paid $7,000 from a company. But at the same time, I have a small condo and I rent this place to someone else. And then every month I got the rental income, which is $3,000. Okay. And then total, my income is $10,000. Okay, so this is my total income. My labor income is $7,000. My capital income from a condo, that's the $3,000. Okay, so here, this example tells us, well, my labor income is 70% and the capital income is 30%. You got it? So in terms of this economy, we can do the same thing. So we have a labor income and the capital income, and together, that's the national income. In fact, the ratio of the labor income to the total income in the States is about the 70%. So the y-axis, the labor share of the total income. So that means the labor income over the total income is about the 70%. And then the question is, all right, so we want to make a very simple model to understand the real world, right? So then we need to have the production function. Like we studied here, when we cover the return scale, we cover this production function like this one is equal to K times L or K squared plus L squared, something like that. But we want to have the, the good one to explain the real world. Then given this fact, so in the States, labor income is about the 70% of the total income, then how can we make a production function given this fact? Well, there are two guys. One is the economist and the other one is a mathematician. And they get together and they came up with this Cobb-Douglas production function, which captures the real world very well. And basically the form is the following: y equals a technology dA times the k to the power of the alpha, L to the power of 1 minus alpha. And here, capital income is a MPK marginal per capital times K, and that is the same as the alpha. So since the US has labor shares of the total income is 70%, so that means that to represent the US economy, the alpha is a 0.7 and 1 minus alpha is a 0.7. Alpha is a 0.3 and the 1 minus alpha is a 0.7. That's why the labor income is going to be about 70% because 0.7 times Y is a 70. Right? And so let's say, this was a 0.7 times Y and this was a 0.3 times Y. So the ratio is going to be 3 to 7. Okay. All right. And this is very famous. So, and it's working very well. So I want you to know where it comes from. And then here, actually this there's a typo. The first one is MPK. And same thing. If you know the calculus and you know how to take a derivative, you can easily find this MPK and MPL. So again, DF, DK, that is MPK, and DF, DL, you take a derivative with respect to labor, then you have the MPL, okay? But you don't need to know. But it's good to know if you study the calculus already. Just in case, let me show you. So when you have the Y production function as a Cobb-Douglas production form, so A times K to the power of alpha, L to the power of 1 minus alpha, when you take derivative with respect to capital, okay? So then so coefficient stays there, this power comes down. I'm using the power rule. And K to the power of alpha minus 1 times L to the power of 1 minus alpha. When you arrange this equation, then you have the alpha times A times alpha times A times, A times K to the power of the alpha times L to the power of 1 minus alpha, and divided by K, then it's exactly the same, right? So then this is same as alpha times Y over K. So that's why we have this one. So here, this A times K to the power of alpha times L to the power of 1 minus alpha itself is a Y. So that's why I replace Y, okay? To make this form, that I use a trick. So K to the power of alpha minus 1 is same as k to the power of alpha over k. You guys following? So one more time, k to the power of the alpha minus 1 is the same as k to the power of alpha divided by k. Okay, and from there you see that this one is exactly same. That's why this part replaced with the y by definition. So then we have alpha times y over k. So that's why we can have this one. Okay. All right. So here we cover the supply side of the market. Okay. Now we need to cover the demand side of the market. But let me stop here. I'm going to make the following following video to make this to cover this demand side.